All right, cool. So, hi everyone. I'm going to start a little bit early. I know it's not quite half past yet, but I've got quite a lot of content to go through, and I wanted to make sure that we finish on time. So, I'm going to be talking about red team, bit of a buzzword, but more specifically, I'm going to be talking about converting experiences and jobs and project experiences that we've all gained from doing projects, etc., right, into tools that we can use in the industry as security professionals. More specifically, I think the talk title I gave was a perspective on research from an offensive security perspective. I'm Vincent Yu, your speaker for today. Right, this isn't on. Okay, here we go. What? All right, so what's the talk about, right? It's about writing tools, mainly, but more specifically, the reasoning behind writing tools, right? And the some of the ideas that I've had and the ways I come about having new ideas to do new types of research, and the process I go through. So it's aimed to help people are looking to do research to understand the process I go through to make these tools happen and make my research happen. And some of the results from the research that I've done and the benefits that we can obtain from doing the research. It's going to be more about getting started in research and my specific journey to share that experience with you all. So if you're interested in writing your own tools, you can maybe learn adapt on some of my experiences to help yourself get started. It's not a rock star talk. It's I don't have any 0 days to share today. But I hope that everyone can gain a bit of insight here, because I've heard a lot of people in the industry where I always get questioned about, hey, I want to do some research, where do I get started, right? I want to write a new tool, what can I do, right? And this is aimed to help those people out there that wanted to get started. So first of all, who am I? I'm Vincent Yu. I'm a consultant at Science Security in Hong Kong. We started around 1.5 years ago now. I've got a bunch of certificates, CREST certified, I've got OSCP, OSCE, ECTPS quite recently because I thought I'd play around with the labs. I'm on LinkedIn and Twitter as well, so if you want to reach out via those channels to ask any questions, I'm happy to chat with anyone as well. So red teaming, right? It's become a buzzword. All the sales guys are using it. Everyone talks about red teaming these days. But yeah, we use the word red teaming, and it attracts a lot of attention in the security industry. But essentially, I like to think of it as like, when we're doing a red teaming engagement, the whole idea is just to understand how well our security investments are doing, right? We've put a lot of money and time into implementing security in our organizations. We want to understand, how well are we doing, right? Has it done its goal of protecting our organization at all? Are we now more difficult to hack? And there's the process of simulating the footsteps of an attacker, right? We simulate according to the cyber kill chain quite frequently nowadays, and that's quite useful, and as we'll see later on in the talk, as to how I select my types of research to do. And the result would be to learn, from the back of a red team, would be to know the strengths and weaknesses of your organization when defending against the unknown. Because if you're always defending against things that you know about, then how do you know you can defend something against something like you haven't met before? And it's aimed to address those types of concerns. So we need tools and research everywhere. I say red teaming here, it's not just specific to red teaming, right? So if we're red teaming a car from this perspective, right, and we're trying to break into this car, we might look at different aspects, right, like the wheels, for example, or the window, or the headlights, or even the cloud if it's connected to the cloud in some way, or the internet, right? We might even look at the driver or someone that's doing maintenance on the car, right? We might try and get in that way through other avenues. And then I see pen testing as more like looking at just the wheels, right, but in more detail, in more sophistication. But there's benefits to both approaches, and the red team approach, I've always been able to see more, from a outside the box perspective. And from a penetration testing perspective, I've been able to look at specific components in more detail. But the takeaway from these slides are, basically, regardless of what your day-to-day role is and what types of exposure you get to, in the security industry, there are areas where you can always contribute with your own research and with writing your own tools, and it will benefit everyone else as well. So, in my opinion, there's the following types of research. There's like the rock star level where people are finding O-days, fuzzing, and all of that good stuff, finding CVEs. all the deep tech stuff. I'm not going to be talking about that as much in this talk. I'm going to try and focus on more of like the ad hoc research type stuff. We find a new area that we're interested in. We want to quickly see whether we can leverage something from that new area of research, or developing tools for that research as well. So I'll be focusing more on the latter two. So tools are really important, regardless of what your role is or what profession you're in. If my laptop broke today and I needed to take it apart to start looking at the internals to try and fix it, I could open up the case in a number of ways, right? I could get a hammer and smash it open, but then my laptop won't look very good, right, afterwards. Or I can actually just use a screwdriver that's designed for the task at hand. And I think the takeaway is, when we have more tools, we can make it more consistent the way we do things, and we can also, we can professionalize the way we do things and make sure that we're less prone to mistakes. We make the task a lot more efficient and easier to complete. So before we had tools, right? This is an example of one of the tools that I wrote a couple of years ago. So we know there's like a PowerShell command, for example, at the top here. We know this is quite easily detectable by antivirus, right? And back in the day when we wanted to change up and break signatures in static files, we had to then start obfuscating the text, etc. And maybe every time we had to make a new payload, we'd go and edit the text manually or even script up elements of it. And we'd have something quite simple, but it'll do the job, right? It's a quick fix, it'll work. And then after we created tools, all we had to do was run one tool against that code, and then we'll have a new output every time, and it'll be consistent. I'll be less prone to mistakes. I'll have less syntax errors, for example, and my code will still work, and it'll do the job. And it's tried and tested, so it works every time. And I can add additional complex features, which I'll show in a bit as well. But before we go into that, I want to go over, so how do I actually decide what I want to research, right, and what to research? One way I do it is by looking at the cyber kill chain. So when doing like a red team engagement, there's like the reconnaissance phase, weaponization, exploitation, whether it's persistence, and then lateral movement in the organization, or actions and objectives, a bit more target specific in those cases. But I've always focused more on the earlier stages, so the reconnaissance and weaponization and command and control phases. I've written tools like DOMLink, LinkedIn to Myint for reconnaissance. I've done a weaponization bit, like Cactus Torch, Morph HTA, and Weaponize. So Cactus Torch was based off James Forshaw's research previously, which I tried to make work, and we can use it as like implants and payload. Command and control, around domain fronting and subdomain takeovers. So I pick things that I know that I can apply straight away into my day-to-day job, and that's how I pick research. So it's a pretty good way to, if you're deciding on something to research, you can pick a specific step in the cyber kill chain and find something that might interest you that you can look into. And from a penetration testing perspective, I've done a whole bunch of things as well. This isn't very specific, but if you're doing a pen test, for example, on a specific technology or web application, right? You might be doing, one of the vendors outside even in the technology booth, right? If you're doing their web application, you might find specific vulnerabilities, or even let's say you find a user enumeration bug that's time-based, right? And so you put in a username, and there's a different delay time if the username's correct or incorrect. You can write up a tool that can do that for that specific technology, right? And you can make that repeatable every time, and you can share that tool, and then everyone else can have that repeatable effect, and we can enumerate usernames from that application. And it's about applying and finding areas that you can write a quick tool for in your specific area of research or day-to-day roles, I think. And another thing I hear quite a lot when, so someone's come to me and they're asking, hey, what area of research can I do? I give them some idea, and then they're like, hey, I'm not a developer. Sure, I'm not a developer. I try and shy away from it as well. I'm not a great coder, for example. So a lot of my code is just patched together. It works. It's not beautiful code. I'm not the best Python programmer in the world. I patch it all together and it works. People give new code updates and optimize my code, for example. And that's because I share my code out there, and I get other sets of eyes, and people can contribute. So like I said, but if the code is somewhat readable, if you make it somewhat documented and readable and understandable, people will actually contribute to your code that you push out there, and they'll keep it up to date, they'll add new features, etc. But more importantly, keeping it up to date, as we'll see with one of the tools that I wrote, the login process broke quite recently, and the community decided to submit fixes. So it's quite useful. A quick slide just to break it off a little bit for me. Oh, thank you. I'm plugging a USB into my own device. Okay. Right, nothing's running. Cool. All right, cool. So just to break off the slides a little bit, for the rest of the talk, I'm going to go over a few case studies of tools that I've written in the past. I'll go over the sort of idea as to why I chose that piece of research, and how I went about doing it, and the process behind it, and some of the results and benefits we gained from it. So Morph HTA, has anyone seen this tool before or used it before? Right, if not, I'll go over it now anyways. But yeah, Morph HTA was a tool that I wrote a couple of years ago because I hit the idea where HTA files are actually used quite often for infecting machines as a malware infection vector. So HTML applications, you can run a JavaScript, a VB script, etc. inside these files. And it's a commonly used vector. A lot of people use it. You might generate it for Metasploit, for example, or a Cobalt Strike framework, etc. There's a variety of ways to get these payload files. But the thing is, it's in the public space, right? So a lot of defenders will be writing signatures for these things, right? Really dumb signatures, like might just find the word PowerShell with like VB script in the same file, right? That sort of thing. But what I found was like, we know there's a common way to fix this issue by just obfuscating the strings within that file. But when you're obfuscating strings in that file, like I said before, if you're going into the file every time and trying to change up the code, or just type that code yourself and mess with it a little bit, it gets really complicated and you're more prone to errors. It can break if you have to test it every code change sort of thing. And it might be 6 months later before you have to do another payload, right? Or even a year later and you don't remember that syntax and you have to go back to VB script syntax. Is it a dot or a plus or an and symbol to concatenate strings, that type of thing. And you might not necessarily want to be fiddling with that when you're on an engagement under time pressure. So, like I said, it's time consuming to do. And also, humans are not really good at being random, right? I can keep copy and pasting the same command to, add more in the file, but I'm not good at being random at all. And a computer can just randomly generate this for me. And I can have custom obfuscation per campaign. If I'm doing a whole bunch of phishing campaigns, then I could generate, maybe like 50 payloads if I want to send every single person a different payload, for example. And I can add fake code paths. I can add benign code that can just make it a lot more difficult to read in different code streams. So if someone's trying to step through the code, it gets a lot more difficult for them. So if you're a bit lost right now, the key takeaway is, this was just a few days ago when I scanned this just to make sure and see what it looks like nowadays. But before you do any obfuscation whatsoever, it's 26 engines will find the static strings in the script, right? Well, that's about half of the virus total engines. But immediately, if there's no sandbox, well, you just don't wait for the sandbox to work yet. But there's around 2 detections on virus total after processing it through the tool. It's 3 years later since I wrote the tool, so I wrote it around 3 years ago. And at that time, it was 0 detections, and now it's 2. So, pretty good. After 3 years, it's still not very detected, and it's still usable. So it's not like the tool's gone out now, right? You can't use it at all. So there is a long-term benefit of writing tools as well. It's actually simpler than you might think, right? You might look at a tool, and I've had people ask this in candidate interviews as well, right? Have you heard of the tool Morph HTA? How does it work, right? Can you explain how it works? How is it bypassing AV? And it's actually simpler than you might think. It's like 4 steps pretty much. The first step is to read the file in, the payload in, and then parse the text of interest, list different sections within the file, and then just process the text, transform the text, change the code up, and then just write it back out as a file. It's just a simple read, process a little bit, and write the file. It's a lot more simple than some people make it out to be. But if you're lost, here's a quick demo just to see what the tool does. So this is the morph HTA tool. Is it gonna start or? Maybe it's starting. Okay, there we go. All right, yeah, there's a bit of a delay. So, we begin by just generating a HTML application straight out of Cobalt Strike, detected by pretty much a lot of antivirus engines, like as said before, 26 out of 52. It's still pretty good, I suppose. You can still bypass some things, but the majority, like people are using Symantec or McAfee, etc., then you want to bypass a lot. Here I run morph HTA with the Explorer mode, so this is another mode that I implemented because our default HTA files spawn out of a HTML application container where if you see like running PowerShell, it might be suspicious, right? You can find like in sysmon, for example, and then the process spawn chain. But here it makes it spawn out of Explorer. And after running the tool, I get a whole bunch of obfuscated code, and it writes it out to pwn.hta. And here I'm just comparing the payloads a little bit. So previously you could see words like wscript.shell and PowerShell, so immediate flags to a defender, and you can immediately see, oh, it's a PowerShell payload. But if we generate this, then it gives the defender a little bit more work to play with. They might have to sandbox it to find out where it's connecting out to. What is it? Is it a PowerShell payload? What is it, right? And they can do a bit more analysis. It gives the blue team a bit more work to play with if you're doing it in a simulated attack. And most important of all, after you do all the processing, you have to still make sure the payload works, right? So I'm just going to run it in this sandbox here, just to make sure that it's still running and I still have the full payload working. Waiting for the sandbox to get infected. It takes a little while. The internet was quite slow in the hotel when I was recording this. But yeah, we've got 2 C2, and it's around a 12 megabyte file. It converted it from around, maybe like 50 bytes or something. Even I don't even know how long it was, but yeah, it's it's added loads of fake code streams, changed up the text, added arithmetic expressions, etc., just to mess with the AV a little bit. So the sort of like key benefits from this tool that I wrote, right, was like we can now reduce the time needed to obfuscate these payloads. If I needed to make 50, or if I wanted to make 100 even, because every single target I'm targeting, I want to give them their own specific instance of a payload so it looks completely different, then I can do that now as well. I don't have to spend half an hour doing it manually. And the complexity and sophistication of these payloads have increased, right? Like before, the blue team could have just looked at the script and saw that PowerShell command, and they knew, all right, it's PowerShell, I can write it in the report now for the incident response. But now they have to do a little bit more. Maybe they have to run it in a sandbox, look at it in Wireshark, or actually try and write a script to parse through the obfuscation. So, it adds a bit more skill, so they have to do a bit more of an exercise when fighting against these types of payloads in a attack simulation. So we're increasing the sort of like value for our customers as well. All right, on to the second tool. So the second tool I wrote was, like I'm going to talk about, is LinkedIn and MyInt. So we know in a lot of attack simulation engagements, we do phishing, right? And phishing is one way that we know a lot of adversaries are breaking into organizations. We've always been getting employee names and details from social media like LinkedIn. Since moving to Hong Kong and the mainland China area, I've realized that a lot of people don't actually use LinkedIn. They use another social media that's mobile-based called MyMy. So I've written tools for both of these types of social media platforms so that I can target more people and get names for more employees. So there's my sort of like injection point as to why I did this sort of research and made this tool. And actually previously, when we wanted to do this, we might have to fire up Burp, for example, and then go through Google and then loop through pages and extract these names and then parse it a little bit, or go through LinkedIn and do the same. It was a bit of a hacky process. But actually LinkedIn is a lot more simpler than you might think. Once again, it's a Python script. It basically connects to LinkedIn, logs in, as you would in a browser, gets a session token, connects to LinkedIn once again, looks for your company of interest that you're interested in, and then gets the employees, passes through the employees, extracts their names and details from the responses, reformats it all and puts it into a nice report sort of format, and then outputs it to a text file, right? So we'll see a demo of that in a moment. Or MyInt, right? So my was a little bit different. They don't really have a web application per se. They have more of just a mobile app. And the difference here was then I'd have to play with the mobile app to intercept the API and make it all work. It isn't that much more difficult. If you've done much mobile testing before, then all it is setting a web proxy on your mobile phone and actually using the application to get all the APIs that you'd need to connect to. So similarly, you log into the API like you've extracted from the mobile application, then connect to that social media network, find that company name once again, get their employees. Even better on My, I found out that you could just dump 50,000 employees all at once if you wanted to. So you don't, whereas on LinkedIn, it was restricted to around 1,000 employees. We'll loop through the pages once again, parse it all, and then spit it out in a HTML template. So here's a quick demo of LinkedIn, just to show you what it does and sort of the benefits if you're not quite aware from just listening to me. So I'll run the LinkedIn tool. Here I'm just going to use Uber as an example. I always use Uber because I've got a bug bounty going on, so it's not as sensitive. So I fill in some fields. Until today, it still works pretty well. And we can see it's extracting employees. The hotel Wi-Fi was a bit slow, so I've speeded up the video a little bit here. We'll see it start shooting through in a moment. So yeah, here it's extracting a lot of employees. It's spitting out some error messages for people that don't have photographs on LinkedIn. But at this point, the tool's finished. And that was within 3 minutes maybe. And I'm able to get roughly 1,000 employees off LinkedIn. Get a nice HTML report template, which I can view. There's nice photographs and the job, the location. I get a lot of Hong Kong contacts because I'm in Hong Kong right now. So it gives me people in the same proximity, people in the same network. You can actually specify a specific location you're interested in, and you can get employees for that specific location. I've got a CSV file as well for the people that want to cut out those emails, for example, and put it into other tools for processing. So you might put it into a phishing framework or into a brute forcing tool, for example, and you can use these as well. So once again, we're reducing the time necessary to perform a repetitive task that we're doing across many engagements. If you're spending less time finding employees of an organization, you're actually spending more time doing something else, right? Whether that be for, doing reconnaissance for other social media or, finding breached passwords, maybe that sort of thing. So you're spending more time on other aspects as opposed to looking for employees. That might take hours in some cases. And there's less confusion now. There's one go-to tool. Before there were loads of other tools, some that use LinkedIn APIs, some that use other methods to getting employees, maybe through Google. But now you just got one go-to tool and you can just, it works and it does the job. It reduces that complexity. All right, so now for the third one, I'm going to give a quick disclaimer. I'd rather if people don't record this if possible, or at least don't share it publicly. Just keep it within the room if possible. Microsoft are already aware of the issues. I spoke to a senior Azure PM. They were like, we know about the issue, we're not, I don't know. It was like half a year ago, or even up to a year ago, and they don't care, so I'm just going to talk about it. And, please just no video and photographs if possible. So it's all public knowledge, though, so you can actually figure this out as well. So subdomain takeovers using the cloud, they're quite popular. We know Azure is really vulnerable right now. Amazon CloudFront used to be vulnerable, but they've added a lot of precautions in place where they're validating your domains before they allow you to use it now in Amazon. Alibaba, there's other clouds as well in the local proximity in the Asia region that are also vulnerable to these types of attacks. I looked at it quite, briefly, not as much in depth because Azure has a lot of good stuff for us, so I play with Azure quite a bit. In this bit, I'll go over what a subdomain takeover is. So it's basically let's say ticketexchange.microsoft.com. This is one that I've identified as being vulnerable. You can, if you've got your laptop right now, you can actually dig for it yourself, and you can see like it's in a vulnerable state. So in step one, right, if you do the dig request, right, you'll see that it actually resolves to a CNAME of ticket exchange.trafficmanager.net. And then in step two, you can see that it doesn't resolve to an A record. So if no one wants to be ticket exchange.trafficmanager.net, so why don't we be that ticket exchange.trafficmanager.net? So, you know, I'll take over it. I'll be that guy. And what happens is, but even after we do that research, right, I don't want to just know that ticket exchange.trafficmanager.net is vulnerable, right? I want to know on a larger scale what companies are vulnerable, what other organizations, what other domains are vulnerable, and I'll go over that as well, right? So what I do is I take a large list of trafficmanager.net instances because I know Traffic Manager uses style at trafficmanager.net, and then I'll loop through all of them, and I can use a tool like Subjack. You can find it on GitHub. And it'll loop through all of them, and I'll tell you whether it's vulnerable to subdomain takeover. There is a lot of false positives here. Sometimes you'll see with the Traffic Manager instance I just talked about, I've reserved control over it, so you can't just go over it and take control over it. So that's why I'm talking about it. But in that case where, you know, if someone's already taken over it, but they're not enabling it, then it'll make it look like it's still in the vulnerable state if you're just looking at the DNS record. We've got our own like private sort of like research and way to do it, to sort of like reduce that false positive rate. But I'm not going to share it here in this presentation. But what we can do is, if we can take that research and we can automate it every month or every few weeks and have this alerting and monitoring system, we can alert of specific domains or even compare vulnerable domains to Alexa Top 1 Million, for example, to assess the impact, etc., and then give ourselves alerts. Or, you know, I can get an email every month to say these are the new ones that we've found. And I can use that to help our customers. If our customer's subdomain is vulnerable, I can use that in an engagement with them for whether like a pseudo waterhole attack, or in command and control, if I want to use their own domain for command and control, or I can use it to phish their own employees. So, you know, I can do that as well. So there are like legitimate uses for these things as well in some of our red team engagements. If you're lost as to what's happening here, here's a quick demo. Here's an Azure Traffic Manager subdomain takeover. Here we're actually on Azure, just to show that, you know, it's not fake, it's on Azure. I've got ticket exchange.trafficmanager.net already registered, but we're gonna dig it again, ticket exchange.microsoft.com. And we can see that there's actually missing A records, right? So there's no A record, and then this pretty much shows that it could be in a vulnerable state. It might not be 100%, but we can register it in Azure Traffic Manager. So I've registered it here, and I've set an endpoint that it goes to. I'd use takeover.megacorp.icu, which I own, and then I can just manipulate the A record to my own servers. So if we go to ticketexchange.microsoft.com, there's no content exists here because it's not enabled yet. And then I go back out to the overview bit, and I can enable a profile. And we'll see that actually quite quickly, if I dig the A records again, the CNAME again, we'll see that now it resolves to my server. So I've got control over this domain at this point. You know, I normally serve a blank page on all of the bug bounties I do as well, because then it doesn't damage the reputation of the organization. But here for this proof of concept, I'm just going to type in some information, some content, some text, refresh the page again, visit the website, and we see we've got control over Microsoft subdomain. So if you're a malicious attacker, right, someone could use this for phishing. You know, you can put like an Office 365 page on it, for example, right? Then suddenly you add a lot of trust for employees. If you're doing this type of research, don't generate SSL certs for these like high-profile domains, because the whole SOC team's going to go after you. So, you know, you'll have some legal consequences. So just like, you know, be careful when doing this type of research. So you will, from the back of this research, know ahead of time if your customer is vulnerable. I've found loads of banks, government entities across the world, and you know, even like national railways, etc., companies, etc. They're all vulnerable to this type of thing. The shipment and logistic companies as well. So there's actually quite a large exposure, right? So if you can do this on the large scale, you can find out a lot of these companies, and then if they're one of your clients, you can help them, right? You can, you know, provide this information to them. And you can simulate attacks that might not have been possible if you didn't have this knowledge. Watering hole attacks have been quite hard to simulate from a red team perspective legally, because we can't just compromise a website on the internet and be that website, right? But whereas if you find that your customer's subdomain is vulnerable, you can use that to then maybe host some content to then phish their own employees. And the last sort of section I'm going to talk about is Azure App C2. So we know from the previous case study that Azure has a lot of subdomain takeovers, right? And Traffic Manager is really easy to play with because you can just direct traffic to a C2 server or a server that you control, rather. But Azure Apps are a little bit more, you can host content on it, but we'll see that it's actually a little bit more difficult. I have to learn these scripting languages like .NET, all right, fair enough, PHP. I have to learn how to write a web app in these languages, which if I'm on an engagement, client's giving me 10, 15 days, I don't have time to be messing around with figuring out how I'm going to start hosting content on this subdomain takeover I found on one of their domains. So what I've done is I've just created a proxy in Python, which just proxies traffic to a selected domain or a selected backend server that you specify. So what I did was I take the connecting client into the Azure app, right? I parse it for the request. I get the GET request, the parameters in the URL body and etc. And then the headers as well, the cookies and other headers. If you're using, I don't know, maybe I don't recommend using the X-forwarded for header, for example, for command and control. But if that was the case, then you need to make sure you're proxying that as well, right? And there's a lot of other headers that might be of interest as well. And then I basically just craft a new request to the target location, so my attacker control server, controlled server, and then just send that same request to my server, get the response, and send it back out to the connecting client to just act as this proxy between the Azure app and my server. So when an incoming request comes in, if I've got bear.png, then I'll just create a new request with that same information. So basically just mirror that exact same request, right? These are some of the things that you have to be concerned with when writing this type of thing. The host header, I stick it as my target server. So we'll see in the demo bit where I actually just configure that, and then it will proxy request to my server. So if you're lost again, here's a demo. So Azure Application Command and Control. So connectme.microsoft.com is actually a domain that I found that was vulnerable to subdomain takeover once again in Azure Websites, right? So there's no A records, you can see it's missing, but we've got this name in Azure Websites. We can go ahead and deploy an application as that name, and we can take over that subdomain. So here I've created this Flask application, which just acts as the proxy. I set the target server to my attacker control server. I run the application. It takes a little bit of time to deploy, so I speed up the video. Right, so it takes quite a few minutes, so we're speeding it up rapidly, like 15 times the speed. And then it's doing all the deployment stuff. It's pushing out this application onto their application cloud. After it's finished deploying, we can then visit the website, but we'll see that it doesn't work. There's a 404 website not found. I figured that actually you can't use the free version. They've been charging me quite a bit of money for doing this, so I've had to go and upgrade my Azure account. So I went and did that. But here I'm cloning Microsoft's website, for example, just as a POC. So I clone that. I refresh it again. It still doesn't work because it's not configured correctly yet. I go to Azure again, click on the application services, click on that instance, go to custom domains. And because it's already pointing to the correct location, I can type in connectme.microsoft.com here and validate this domain actually works. Go down, and I can add it as a custom domain. Now if I refresh this website again, we'll see that connectme.microsoft.com actually hosts a website that looks like Microsoft's website, right, on my own server. But the key point of this was to make it work for command and control. So I'm going to generate a malware executable here and then run it in the sandbox just to make sure that I'm actually connecting to connectme.microsoft.com and it's actually working as two-way C2. So here's the sandbox. I'm just going to paste it in. I've got Wireshark running so we can monitor like the C2 is actually working. I don't use HTTPS because I don't want to make any SSL certs under Microsoft's domains. So C2 channel is working. I check over in Cobalt Strike to make sure that the full two-way C2 is working. I censored that a little bit because I didn't want to give out too much about my C2 channel. So yeah, if I do a screenshot, it'll work because there's the two-way command and control working to the connectme.microsoft.com, and we can see there's a screenshot of the sandbox. It's a bit cut off because high DPI on the sandbox, and I didn't screenshot in the right application. But if we look at the DNS records, we can see that it's actually going to connectme.microsoft.com. Yeah, so by doing this research, I'm now able to have command and control over subdomain takeovers that are on Azure applications. And a lot of Azure applications have actually used a lot more than Traffic Manager, and a lot of banks and like even financial organizations are actually vulnerable to these types of takeovers. I've found a bank in Hong Kong, for example, that was vulnerable, and I communicated these findings to them as well. But if it was your client, then you might be able to use one of their subdomains to use it as a C2. And if you're the blue team and you see this, right, in your dashboard, you're like, hey, did one of my, our cloud domains get compromised or something, right? So, it adds this bit of interesting situation to the attack. And we can increase the sophistication a little bit. So yeah, that's about it. But the key takeaways are, I think it's really important to decide on what type of research you want to do. Like I said, I normally pick it from the cyber kill chain, somewhere in that kill chain if possible, so I can know I can directly apply it again to my work. You could do the same as well. And a lot of the tooling that I write is, it's hacked together. There's no fancy GUI, etc. There's no, I'm not a GUI application guy. I don't write much bootstrap code. So I can't make it look fancy, right? It's not got a dashboard, but it works. It does the job. And I think people shouldn't shy away from writing tools, even if it's a simple concept. I've had people say, why are you writing a tool to do a few DNS lookups? But to me, right, it works. It does the job every time. And they don't have to remember those exact things to look up, right? Hence why it's going to be useful. And always share the tooling if possible. The community will help you evolve and update your tools as well. So thanks a lot. I'm Vincent Yu. Find me on Twitter if you're interested, and send me a DM or something to ask about anything. If you've got any questions now, I can take it as well, if we've got time. Yeah. Might have been a bit fast, so. Yeah, okay. Yeah, okay.